Welcome to Ask and Learn.
So in question 86, we say high voltage supply can be constructed from a variable capacitor with interleaving plates, which can be rotated from figure 36. Okay, so in figure 36, we have a couple plates. Pardon my drawing. Is in some way sort of fixed. We have some other that can be rotated. We have some other plates that can be rotated. Okay, rotating plates was also on axis. So this is a set for question 86. If you have done question 85, you probably already have some idea of how it works. So a version of this type of capacitor with more plates have a capacitance which can be varied from 10 picofarad to 1 picofarad. Okay, so initially this capacitor is charged with 7500 volt. Power the capacitance is 8.0 picofarad. And then it's disconnected from the power supply, and its capacitance is decreased to 1 current. So ask, what is the voltage across the capacitance now? Okay, so the voltage will change, but the amount of charge on the plate is fixed. So because of that, we can just use the conservation of charge on this plate to figure out. We have Q equals CV constant. So C1V1 equals C2V2. So V2 just equals C1V1 over C2. And that is 8.0 current times 7500 volt over 1 pico. So the voltage goes up to 123. Yeah, to 6 volt. So that's how you achieve a high voltage with this type of device, because by decreasing the capacitor or keeping the charge constant, by decreasing the capacitance, you are increasing the amount of voltage by 8 times in this case. So that is part A. Part why is there any disadvantage? Okay, so I mean, if we think about it, if we use these type of things as this variable capacitance is a high voltage power supply, once it discharges, the voltage drops and then it needs to be recharged. So it is not a constant source of voltage, high voltage. I mean, it's more like a voltage converter that you already have some voltage and then you convert it to higher voltage. But then once you use up the voltage, that is it, because it's like a battery. It doesn't produce voltage on its own. So I think that is one major disadvantage of this, that it can give you voltage bursts, but it can't give you not a constant voltage source. Also, another thing is that usually capacitor materials has a limit of how much voltage it can sustain. So in general, capacitances are not really a good thing to store high voltages, because material usually break down before that. You have to use, like, high voltage batteries have specific materials designed for high voltages, but this thing is designed as a variable capacitor. I think, let me see. Finally, I would say the capacitor is small, so the amount of energy is 1 CV squared. I mean, even though it's high voltage, it's still like a small capacitance. So it actually, if you calculate it, you'll get 1.8 millijoule, which is very. So really, as I said, it's not voltage, so it really doesn't change the voltage burst so much. It has such a small amount of energy that you can only like get an extremely short voltage spark, and that is it. So it's not really useful for constant voltage supply.